Part 1. Upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead, the elves discovered an assortment of notes and lists of historically significant locations. This seems to be the planning the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to enter. Throughout the chief's office, the historically significant locations are not listed by the name, but by a unique number called the location ID. To make sure they don't miss anything, the historians split into two groups, each searching the office and trying to create their own complete list of location IDs. There's just one problem. By holding the two lists up side by side, your puzzle inputs, it quickly becomes clear that these lists aren't very similar. Maybe you can help. The chief historians reconcile their list, for example. So we have 3, 4, 4, 3, 2, 5, 1, 3. All right. So first list, second list. All right. So maybe the lists are only off by a small amount. To find out, pair up numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list, and so on and so forth. So if you sort them in alphabetical, in ascending order, first number to the first number here, second to second, so on and so forth. All right. So in the example above, the pair and distances would be as follows. Smallest number in the left list is 1, right list is 3, distance is 2. So again, it's like absolute difference. Make sure of that. Because 1 minus 3 would give you -2, so absolute difference. And yeah, just goes to basically say, okay, third number is this. Yeah, all right. So to find the total distance, which is the main point of it all, we take the difference. So for this number, subtract the absolute difference with this number, do that for all, and then sum them all up, and we get what we're looking for. So what was my solution to that? We get our inputs as vec of strings. For those who don't know, in Rust, it's like a list of strings. So the way the input is received, the way I parse it from my utils class, I say, okay, each line is the string. Each line is a string in the vector. That's how it is. So it's like split lines, you could say. So yeah, we parse that input, and here what we do is that we say, okay, for each line, we take a map and we map that line and split it into two things. The first number parsed as a U32 and the second number parsed as a U32 too. And then we use a fold, so to go through each pair that you have, shove the first number into the first list, shove the second number into the second list, and I'm blocking this here. So if you don't know what fold is, you basically go through a list, and it's like an accumulate, right? So we basically have two lists, first list, second list. That's why we come here, do a bit of destructure in here to get the types out, to get the list out. Then we sort them. Sort unstable is just quite faster and doesn't allocate. So yeah, you can look into that. Basically, it sorts them, and it sorts, okay. So after doing that, we iterate through both lists at the same time into list 1, list 2. Zip just pairs them together. So again, like the question said, first number with the first number here, second with the second, and that's what zip does. And then for each pair we have, we take the absolute difference of subtracting the second list from the first list. I don't think I actually said that here. So yeah, that's what we do. So 3 minus 1, so it's actually not 1 minus 3, it's 3 minus 1. So we map both pairs A, B, and then, so since it's absolute difference, my calculation actually doesn't mirror what they want. They want A minus B absolute. They want this, A minus B. What I actually did is B minus A, which still gives the same answer. I mean, they are equivalent because of the absolute difference. It doesn't make any difference. But yeah, to be more accurate, in quote, if it was A absolute difference B, that kind of reflects what this is. So yeah, anyway, it doesn't really matter. So after doing that, we then sum all the numbers up, which is basically the answer. So take the difference, sum it up. That's it. That's part one. Part two. Part two. Your analysis only confirmed what everyone feared. The two lists of location IDs are indeed different. Very different. I did not read that at all. I read from my mind. Or are they? The historians can't agree on which group made the mistakes or how to read most of the chief's handwriting. But in the commotion, you notice an interesting detail. A lot of location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. This time, you would need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times it appears on the right list. Here's an example. So the first number in the left is 3, appears 3 times in the right list. Second number is 4, appears once. So 3 here appears 3 times, 4 appears once, 2 appears none. So it will be 2 times 0. 1 appears none, so again 1 times 0. 3 appears 3 times. 3 also appears 3 times here. And we again sum that all up, you get 31. Now, what's our approach to this? The naive approach is to say, okay, for each number here, take a loop and check how many times it occurred here. And again, do repeat that over and over again. That gives you like an n squared time complexity, which is fine. I mean, for this, it does work. But an optimal approach, which I thought of after the fact, after I did this, an easier approach would be, okay, for this list, shove it into a hash map, and with the key being the number and the value being the frequency, how many times it occurred in the list. So 4 will be mapped to 1, 3 will be mapped to 3, 5 mapped to 1, 3 is the same 3 here, 9 mapped to 1, and then walk through this list and say, okay, and then you are querying the map you just built. Be 3, okay, how many times do you occur here? 3, 4, how many times do you occur here? 1, 2, how many times do you occur here? 0, because it wasn't in the list, so it's 0. 1, 0, 3, 3, 3, 3. Time complexity for that is ON. ON to build the loop, ON to query, because querying the hash map is O1. So yeah, that's kind of what we do. What I did, which is a bit more convoluted, is we map the number here to two things. The first value of the tuple is how many times it occurred in the first list. The second value of the tuple is how many times it occurred in the second list. So for 4 here, 4 maps to 1 being how many times it occurred in the first list. And if, for example, 4 mapped to 2 here, it would be, okay, this 2 is the amount of times it occurred in the second list. So if this was 4 here, for example, it would be 2 here, 1 here. And for 3 will be mapped to 3 and 3, because it was 3 times in both lists. So 3 and 3. So that's what we do. So the first list, just, okay, tally map dot entry, basically like a get, but with the ability to add if you didn't find. So entry gets whatever number we're assigning on, so for example 3, and if it does exist, we say, okay, take the first number, which is how many it occurs in the first list, and add 1 to it. Else add 1 and add 0. So we assume that it did not occur in the second list because we haven't seen it yet. So we assume that to be true. So we do that for each and every one. And from the second list, we say, okay, go through that list, query it. Okay, so 3, if it does exist, modify the count. So the count's raise it from 0 to being 1. If it didn't exist in this list, then it really doesn't matter at all. We just disregard it. We just discard it. And that's it. So that's how we build our map. And for each map, take the key, tally, and count. Multiply the key by the count and the tally. Why do we do this? Key multiplied by count is basically what you see here, right? 3 multiplied by 3. So 3 multiplied by how many times it occurred on this list. But the tally, remember I told you, tally tells you how many times it occurred in the list 1. Now, tally would basically be, which is called 3 times, so 3 times 9, that would give you 27. That's basically what we do. So we kind of like compress everything. The other hash map solution was a bit more clear on what's happening here, and I believe it saves you from one extra for loop down here. But yeah, that's day one solution. So hope you guys enjoyed that, and see you guys on the next one.